We are going to be doing some practice sample calculations for different circuits. So first, let's review the difference between how we find things for series and parallel circuits. So first of all, we have our total resistance. For a circuit arranged in series, we just add up all of our values of resistance. And for parallel, it's the inverse of the sum of the inverses of each resistance. And I will demonstrate how to calculate that properly later on in this video. Our voltage for a series circuit is equal to the sum of the voltage across each resistor, and in parallel, the voltage is the same across each resistor. And then it's the other way around for current. In a series circuit, the current is equivalent across each resistor, and in a parallel circuit, the total current is the sum of the current across each resistor. And then Ohm's law is the same for both a series and parallel circuit, where our voltage is equal to the total current times the total resistance. And so we're going to be using all of this information to do some calculations on 3 different circuits. So the first one we're going to take a look at is this one, and just study it for a moment and determine if you think this is a series or parallel circuit. Remember, a series circuit only has one path for the current to travel, and a parallel circuit has more than one path. So this is a series circuit, and we have 3 different resistors here. So the first thing we want to find, apologize for that bell, the first thing we're going to want to find is the total resistance. Now, because this is a series circuit, we're going to find that by adding all of our values of resistance together. So our total is going to be 220 ohms plus 470 ohms plus 1.2 kilo ohms. That is the same thing as times 10 to the 3rd power. So that's going to be 1200 ohms. And so my total resistance for this circuit is 1890 ohms. Now, using that information, I can use Ohm's law to find my total current, because I now know my total resistance. So remember, V total is equal to I total, current total, times total resistance. And I want to find I, so if I rearrange this by dividing by the resistance on both sides, my total current is going to be the total voltage divided by the total resistance. And so for this circuit, we know that my total voltage is 12, and we just found our total resistance. So that means that my current is approximately 0.0063 amps. Okay. So also in a series circuit, we know that the total current is the same across each resistor. So my current is going to be the same value on each resistor, but what's going to be different is my voltage on each resistor. So let's find the voltage on each one. So my voltage for resistor 1 is going to be equal to my current on resistor 1, which is the same as my total current, times my resistance on resistor 1. So that's going to be 0.0063 times resistor 1 is 220 ohms. So that voltage is approximately 1.4 volts. We're going to do the same thing for resistors 2 and 3. My total current times the resistance on resistor 2. And that's going to give me about 3.0 volts. And lastly, current times resistance 3 gives me approximately 7.6 volts. So that is the voltage across each individual resistor. And remember, the sum of all of those voltages should equal my total. And I know my total is 12, so let's verify that together. So 1.4 equals 12. So the sum of V1, 2, and 3 does equal my total voltage. And that completes our calculations for this first circuit. And we are going to move on to another one. So first, taking a look here, is this a series or parallel circuit? And if you said parallel, then you are correct because there is more than one path for the current to travel. So let's review. Again, we're going to first find our total resistance, and in this case, it's the inverse of the sum of our inverses. So that sounds trickier than it really is. So let's set this up together. Again, I have 3 resistors, and so my total resistance is going to be 1 over 1 divided by 470 plus 1 divided by 2.2 kiloohms. Remember, that's just multiplying it times 10 to the third. And then 3.3 kiloohms. This is how I find my total resistance, and this is what needs to go in your calculators. So one way that you can do this, my batteries are low, is first add everything in the bottom. So 1 divided by 470 plus 1 divided by 2200 plus 1 divided by 3300. And then divide 1 by your answer, and that will give you your total resistance. So for this circuit, my total resistance is about 346.6 ohms. Okay? Now, using that, I'm going to solve for my total current because, again, I'm given my total voltage. And just how we rewrote it in the first circuit, my total current is equal to my total voltage divided by my total resistance. We know our total voltage is 15. We just found that our total resistance is 346.6. So, in this circuit, my total current is about 0.0432 amps. So now, again, we're still working with a parallel circuit, and in a parallel circuit, my voltage is the same across each resistor, but the current is different across each resistor. So we're going to find the individual current on each resistor, kind of like we did with our voltages in the first current. So if I'm looking for the current across resistor 1, that's going to be my total voltage divided by the resistance in resistor 1. So my total voltage is 15. The resistance on resistor 1 is 470. And so my current is approximately 0.0319 amps. And we're going to do the same thing for the second resistor. And I get 0.00682 amps. And same thing for our third resistor. We get 0.00454 amps. And so, just like on our series circuit, the total voltage was the sum of them all, that is the case for our current in a parallel circuit. So let's verify these 3 values should add up to my total current. So let's verify that. And we get 0.0432 amps. And so that checks out. Okay, so let's now shake things up a little bit and take a look at a combination circuit. So this is going to have both series and parallel. So take a look at this for a moment and think about where the parallel is and where the series is in this circuit. So wherever I have more than one path for my current to travel is a parallel, and where there's one path is series. So resistors 1 and 2 are arranged in parallel, and resistors 3 and 4 are arranged in parallel. But the individual portions are arranged in series. So to find my total resistance, I need to find the sum of these two as arranged in parallel and these two arranged in parallel, and then I'm going to add them as I would in series. So that sounds a little trickier than it really is. So first we're taking care of our parallel portion of our circuit. So if I want to find the sum for resistor 1 and resistor 2, I have to add them the way I add resistance for parallel. So the inverse of the sum of the inverses. So 1 over 100 plus 1 over 250. And again, if I'm going to do that in the calculator, let me put what's on the bottom first. And then divide 1 by the answer. And we get about 71.429 ohms. Okay. And then we're going to do the same thing for resistors 3 and 4 with their values. And again, we get about 127.27 ohms. Okay, so that took care of the parallel portion of my circuit. Now let's look at what we have arranged in series. And that's going to be my combination of resistor 1 and resistor 2 plus my combination of resistor 3 and resistor 4. So I get to add those two values above. And my total resistance for this circuit is about 198.7 ohms. Okay. Now again, we already know our total voltage, so let's find our total current. We're going to do that same thing we've been doing, where the total current is equal to the total voltage divided by the total resistance. So 24 divided by 198.7 gives us approximately 0.121 amps. And I'm running out of room, so let me grab a second page. We are actually running low on time, so I'm going to have to start a second video, but I do want to show you what we're going to be solving for in that second video once I also get my second sheet of paper. So if you will recall, in a series circuit, remember our voltages are different across each resistor, and in a parallel circuit, our currents are different across each resistor. So what we are going to find is voltage 1 and voltage 2. And then we're also going to find current 1 and 2 and 3 and 4 across our 4 resistors, and then the voltage across our series set of the circuit. So stay tuned for part 2.